Hello, everyone. This module, we're going to talk about a new module this time. It's on logic. Sometimes you can call the mathematics of logic. We finished sets. We finished the mathematics of sets. So when we introduced sets, we talked about operations on sets. Namely the intersection, the complement, the union, the Cartesian product, and the difference. Well, this time I'm going to introduce a brand new mathematical object called statements or logical statements. And we are going to follow pretty much the same idea is once we talk about the definition or we define statements, and then the next step is what are the operations on statements, and we are going to see some of the real life applications of that. So let's dig in. So this is the first section, 3.1. So once we're done from this section, you'll be able to identify a statement, a logical statement, and we'll be talking about what's called logical connectives, which pretty much the operations on statements. And we'll understand what's called the quantifiers. There are two quantifiers. You will get to hear me talking about that in a moment. And if you have two or more statements connected by logical connectives, you obtain what's called a compound statement. And then we'll talk more about what's called the if then and if and only if, which are nothing but operations on statements. I know at this point of time it's confusing and it's not making any sense, but just be patient with it and we'll introduce things little by little and you will have the chance to understand every single word I just said. Okay, so what is a statement? A statement is just a sentence. It's an English sentence that can be judged as either true or false. Yeah, if I say to you something and then you quantify or you say, well, true or false, then what I just said is a statement. For example, I'm going to say Florida is a state in the United States of America. Is this true or false? Well, it's true. So what I just said, Florida is a state in the United States of America, is a statement. But if I say, how are you? Well, you cannot say true or false to how are you? So this is not a statement. So whenever you say true or false, whenever you evaluate something to be true or false, that thing is called a logical statement or just a statement. We're going to use the word statement for short. Okay, this is just like I said, it could be either true or false. So when you have just one statement, the one I just used before says Florida is a state in the United States of America. This is just one simple statement, it's just one sentence. But sometimes I can have what's called a compound statement, more than one statement. For example, it says Florida is a state in the United States of America and I live in Texas. So here, the whole thing can be either true or false, the whole thing. But the whole thing, if you heard me saying, if you heard me, I would say, with attention, you realize that I said actually two things. I says Florida is a state in the United States. That's one thing. And I used the word and. And then the next statement said, I live in the state of Texas. Well, I don't live in Texas, I live in Florida. So here we have what's called a compound statement. So, but when you have a simple statement, or a simple statement, nothing but a sentence that conveys only one idea, right? One idea, not two things. And of course, at the end of the day, whether you have a simple statement or a compound statement is going to be either true or false. So let's go back to the example I just said. Florida is a state in the United States of America, and I live in Texas. Well, the whole thing is false because I don't live in Texas. But if I said Florida is a state in the United States of America, or I live in Texas, well, the whole thing is true because I use the word or. So later on, we are going to pay attention to these connectives, and we're going to make the difference between and or and if and so forth. Well, the statement I just gave you about Florida and me living in Texas is called a compound statement. So a sentence that combines two or more statements, simple statements. Well, here's the first operational statement called the negation of a statement. The negation of a statement, it changes statement to be its opposite meaning. Well, what is the negation of I live in Texas? The negation of that is I do not live in Texas. As simple as that. So if you have something true, the negation of it becomes false. If you have something false, the negation of it becomes true. And of course, when you do the negation of a statement, you obtain a new statement. It's just of opposite truth value. So what you hear or what you read now on the slides is just what I said. The negation of a true statement is always false and vice versa. Now let's talk about quantifiers. The word quantifier means, well, actually there are two, but there are, from these two quantifiers, we are going to, obtain more. When you have a word such as all, you see that word all, or none, or some, these are quantifiers. If I say all students live in Florida, so I just use the quantifier all. If I say some students live in Florida, I use the quantifier some. So pay attention to these words all, none, or no, some, etc. These called quantifiers. Well, there is a big issue about what happens when I negate a quantifier. For example, I would like you to pause I'm going to ask you a question. I would like you to pause this lecture and think about it. Suppose I say, here's my statement. All students live in Florida. I'll say it again. All students live in Florida. So what is the negation of that? Can you tell me? The negation of all students live in Florida. Are you going to say all students do not live in Florida? That would be wrong. So here's the table that will allow you to negate things properly. If you have all are, if you have all are quantifier, the negation of it becomes some are not. So if I go back to the example I just told you, all students live in Florida, the negation of that would be some of the students do not live in Florida. Non-are, the negation of non-are. So whenever you have a statement that has non-are, and if you are asked to do the negation of it, you should say some are. Some are, the negation of some are becomes non-are. And some are not, when you negate that, it becomes all are. It would be a little bit confusing at the beginning, but once you get used to it, it's not that bad actually. It's just this table is really important table. Just keep in mind, maybe you can write this on a piece of paper or an index card or something. And then whenever you have a quantifier in a statement and they ask you to negate, to use the negation of that statement, just pay attention to which of the cases are in that sentence, in that statement, so you can properly negate the given statement. Or in another way, another representation, here's a negation. The negation of all are is some are not. The negation of some are is none are. Or it goes back and forth. If you have none are, the negation of it is some are. If you have some are not, the negation of it is all are. Okay, here's an example. Write the negation of the statement. Some books are novels. Well, here's some, you see, here you have this situation here. Some books are novels. So if you negate that, it becomes none of the books is novel or is a novel book. Yeah, so as you can see here, the solution, since some mean at least one, the statement some books are novel is the same as at least one book is novel. So because this is true statement, the negation must be false. The negation is no books are novel, which is a false statement. Well, maybe, again, this may sound too complicated, and I agree. For somebody who's seen this for the first time, that sounds, this paragraph is too confusing. But if I go back to this here, It's pretty straightforward. It says some books are novels. The negation of that, none are. So as you can see here, so at the end it says no books are novels. Some books are novels. So take the negation of that, it becomes no books are novels. So again, go back to this and see which case you have. If they said all all books are novels, the negation of that would be some of the books are not novels. And that's it. Here's another example. All coins have the image of George Washington, right? All coins have the image of George Washington. So what they say, write the negation. What do you have? You have all. So if I go back again, I have all. So the negation of all is some are not. So if I go back to the example, all coins have the image of George Washington. The negation of all that is some coins have the or don't have the image of George Washington. And of course, some have. See here, some coins do not have the image of George Washington. Okay, now let's talk about compound statements. So compound statement, like I said at the beginning, it's just a statement combined with simple statements. And these are the connectors. So the connectives or the operations to use on statements are the and the or and the if then and if and only if. Yeah, we are going to learn how to deal with each of those connectives, and we are going to see the effect of the and versus the effect of the or and so forth. And the next actually statements, we're going to dig more into more mathematics or logics into those things. Well, here they should have included the negation. In other words here, just to give you an idea about what's going to happen next is we have the negation as one operation. We have the and, the or, the if then, and if and only if. These are the operations on statements. So there are 5 of them. Just like if I ask you what are the operations on numbers, if I'm working with numbers, what are operations? Well, you can add them, you can subtract them, you can multiply by one the other, you can multiply them and so forth. What are the operations on sets? Well, you can do the intersection, you can do the union, you can do the difference, you can do the Cartesian product, you can do the complement, remember? Well, here, those are on statements. So if I'm having statements, these are the operations that are allowed on statements, and these are the operations on numbers, and these are the operations on sets. This is just to give you the idea of where we are heading. So here we are doing what's called the mathematics of statements. So we are going to take time and talk about the negation, talk about and or and all these operations one at a time. So the negation first. Well, just like I said here, I could have, if I could have said, I could have put here addition, right? To add 2 numbers, but they use a symbol plus. They use a symbol hyphen to say subtraction. This one to say division. This one to say multiplication. So for each of those operators, or for these operations, we are going to have symbols. And here is the symbol for the negation. It's just this tilde here, right? This is the symbol. Some people use this symbol like half a rectangle, but we are going to use this one here, so it's going to be consistent with the homework system. It's just a tilde. I don't know if they call it tilde. It's you have it on your on the keyboard, right? If you look at the keyboard of your computer keyboard, you should see something like this if you want to write it down. And you can read it not, or the negation of. So if P is a statement, what is P, by the way? P is a statement like I live in Texas. It's a statement. I call that P, remember? When we did sets, we use capital letters. Yeah, we work with set A, set B, set C, etc. In algebra, we use lowercase letter. We use X and Y and Z and so forth, T and so forth. While in logic, we use lowercase letters to denote statements. P is some statement. For example, P is I live in Texas. So what is this? This is not P or the negation of P. So read this as not P or the negation of P. Okay, so we're done from the negation. Let's do now the and statement, the and. Sometimes known by the conjunction. Remember, this is the list of statements, right? So the negation here, let me see if I can change color. So the symbol for this one is tilde. The and, the symbol of it is the, I don't know how you call this, wedge. Yeah, wedge. The symbol we're going to use for the or is the, the V. The symbol for if then is the arrow, and the symbol for if and only if is the double arrow like this. Just again, just like I use the plus and the minus and the division symbol and the multiplication, for each we use symbols. Remember I told you before, we use symbols, so we don't write a lot of words. That's pretty much it. Yeah, so here we did the negation. Now we're going to talk about the and statement, and the and called the conjunction, and the symbol for it, like the wedge. So the conjunctions of two statements P and Q is P and Q. You read it P and Q. You don't say P upside down VQ. Well, you could say that if you want to, but the proper way of saying things is P and Q. I live in Texas, and today is Friday. So P is I live in Texas. Q is today is Friday. So this is P and Q. So in other words, that might be used to express a conjunctions. Well, and here, excuse me to be a little bit confusing. So here they use the word and, right? And sometimes they use the word but or however, and nevertheless. You see, you can say, I live in Texas, however, my father works in Florida. Well, how do you translate this in symbols? Well, you use the and. So when you have however or but or nevertheless, then they are pretty much meaning the same meaning as and. So because in some exercise, they will give you a paragraph and they ask you to symbolically write the paragraph, right? Just convert it into symbols. But when you have the word but, it says, well, I don't know how we're going to replace the word but with. Well, you replace it with the conjunction. The conjunction symbol. Okay, well, here's an example. Write the following conjunction in symbolic form. So what does this mean? Again, translate this sentence into symbols. So it says, Kanye West is not on tour, but, you see here, but? So this but here would be translated into this symbol. But Kanye West is recording a new CD. So here we have two statements that are connected by this conjunction symbol. So the solution, so if you present, for example, the first one by T, so what is T? Kanye West is on tour. And what is R? Kanye West is recording a new CD. So how are we going to replace the given statement? Write the following in symbols. Kanye West is not on tour, means the negation of T, right? And Kanye West is recording a new CD. So this is the symbolic representation of the given statement that gave us at the beginning. Well, what happened if they chose to call this, what happens if they choose to say Kanye West is not on tour, then you just replace, you remove this, I would say, the negation symbol here. So it all depends on what you have used the letters for, and then based on that, then you symbolically represent what's given to you. Okay, so we did the negation, we did the and, now we're going to do the or. Well, the symbol for the or is the V. Well, of course, you don't read it V, you read it or. For example, in this book, the or will be, well, when they say, I thought this is an example. Well, in this book, in this discussion, in this lecture, the or will be the inclusive or. So because we have two ors, we have the inclusive and we have the exclusive. This may be a little bit confusing. Sometimes the other one they call the XOR. But you may forget about this little discussion till later on. I don't think we're going to have any issues when we do the homework or the test or anything when it comes to it. We have only one OR. How about that? Just when you read the OR, it means the conjunction. I'm sorry, the disjunction, and this is the symbol for it. And when you say the disjunction of P and Q is, well, P or Q. Well, here is an example. Suppose that P represents Camilla will take chemistry, right? Camilla will take chemistry is a statement called, that's I denote that by P. And Camilla will take French, this is Q. So write the statement in symbolic form. So Camilla will take chemistry or Camilla will take French. Well, how can you translate this? How can you translate this into symbols? Well, it says Camilla will take chemistry. Yeah, so that's P. The OR will be translated into the disjunction symbol and Q. So that's Q because Camilla will take French is the Q. So the solution is P or Q. Here's another example. Camilla will take chemistry, Camilla will take French. Okay, now how are you going to translate this into symbols? Camilla will not take chemistry or Camilla will not take French. Well, now we're going to negate the P and negate the Q and use the disjunction operator in between. So Camilla, it is not true that Camilla will take chemistry, or it is not true that Camilla will take French. Or you can say Camilla will not take chemistry, or Camilla will not take French. So when this is what we talked about this before, compound statements, when you have two statements connected by and or if and if and only if. So let's look at this example here. Suppose P is to say dinner includes soup. Q, dinner includes salad. So we have two statements. Well, actually we have three statements. P and Q and R. And what is R? Dinner includes the vegetable of the day, right? So those are three simple statements. Now, based on those letters, they are asking us to represent this statement. It says dinner includes soup and salad or vegetable of the day. How are we going to translate this into symbols? It says dinner includes soup, that's P, and salad or vegetable. And well, here it's a little bit, so you may ask yourself, well, how can I tell where to put the parentheses? Well, kind of like from the context of the statement they gave you. So for sure, dinner will have soup. Now the dinner will have either salad or vegetable of the day. Now, is it an XOR? Is it an exclusive or? No. You may have a dinner in this situation has soup and salad and vegetable of the day. So the or is not this or not or the other. You see, it's like when you say, for example, in real life, you can say, I am going to eat dinner at let's say Panera or at somewhere else. I don't know, at McDonald's, right? Here, the or that you use is the exclusive or, because you cannot go to Panera and go to the McDonald's at the same time, right? But the or here in our discussion, when you have or between two statements, there is, you can have both statements true. So both can apply. Okay, how about now? Dinner includes soup and salad or vegetable of the day. You see the comma here. Maybe I went a little bit fast on the previous slides. The comma here tells you kind of like do this, right? So I'm going to have the parentheses. Dinner will include soup and salad, and then the rest. Look at the parentheses, like the position where you are going to end the parenthesis. You see here? So dinner includes soup and salad. Here it is. P is soup and Q is salad, right? Or vegetable of the day, and then or R. Okay, here's another statement. P, the house is for sale. Q, we can afford to buy the house, right? The statement is symbolic form. Well, here, they are asking us to do the opposite. They gave us the symbols and they ask us to write down the paragraph. So how are we going to go backwards? So what is P? Remember, this symbol here, this wedge, will be translated into and this tilde will be translated into negation. So here, what is P? The house is for sale. You are going to say the house is for sale and we cannot afford to buy the house. That's what it is. Yeah, so that's how it goes. So we want backwards from symbols to, to plain English. How about this one here? We're going to say, well, again, you got to go back and see, review what's P and Q. Here's P. P, the house is for sale, and Q, we cannot afford, or we can't afford to buy the house. Here, the house is not for sale, or we cannot afford to buy the house. Well, there is a typo here for sure in this slide here. You see here, this is the or. So this is a typo on the slide. This really should be or. We cannot afford the. That's the or, not the end. So they made a typo. So this is the or. So when we go back from symbols to words, we need to replace this with or, not with and. Yeah. Now, this statement as it was before was correct if they had the negation of P and the negation of Q. Now this will be translated into and. So they had an error there. So how are we going to translate this? So when you have the negation outside, you can say it is false, right? So this one here, you can always replace by it is false that. That what? That this thing here. It is false that the house is for sale. And you see that? This is the end. And we can afford to buy the house. Okay, so far we worked with the negation. So just to recap a little bit, we worked with the negation, we worked with the and or. Now we're going to move to what's called the if then statement. So we did this. We finished these three here. And we are going to focus on the what's called the if then statement. And it is now by the conditional. This statement is now by the conditional. So again, the conditional, the symbol for it is just the arrow going in this direction. We talk about the antecedent is the part of the statement that comes before the arrow. So here we are going to have P. We are going to have if P then Q. P then Q, and this one is called the antecedent, and the Q is called the consequent. This is called the consequent. And this is just jargon. This is definition. Just in case if you read the book or you read something, they talk about the antecedent, and then you talk about the thing that comes right before the arrow. And if they talk about the consequent is the thing that comes after the arrow. Just definitions. So when you say if P then Q, you symbolize it by P arrow Q. Here's an example. Suppose we have these two simple statements. P is the portrait is a pastel. Q, the portrait is by Beth Anderson. By the way, when you read statements, you don't have to understand art or understand what, and just you have two statements. That's all you care about. right? That's all you care about. So let me translate this, we gotta do the same game we did before. We are going to translate this into symbols, right? You write the statement in symbolic form. Here is the statement. If the portrait is a pastel, then the portrait is by Beth Anderson. Well, as you can see, we need to pay attention to the word if, then. So if P, this is the statement P, and this is the portrait is by Beth Anderson, that's your Q. So we're going to say P arrow Q. That's how you symbolically represent this statement. P arrow Q. So whenever you read something and you have if, then that becomes a conditional. Well, here is another one. It says if the portrait is by Beth Anderson, means Q arrow, then the portrait is not. So then the negation of P. That's how you translate that, right? Okay. It is false that, so you see, it is, every time you said it is false that, then you start with the negation. It is false that what? If the portrait is by Beth Anderson, Q, then P. Yeah. So this is just how to move from word to symbols. And then they are going later on when you do the homework, they will give you the opposite direction. They will give you symbols and they will ask you to write down the English translation of those symbols. Okay, so this is how to read or how to interpret something that has the word if then. Again, we did the negation, we did the and, we did the or, and we just finished the conditional, the if statement. And now it's time to talk about called the if and only if. Later on in the next lecture or next videos, we are going to be talking more about these operations, and we are going to investigate how to, to work with them, how to do what's called the truth tables of them. It's just like, imagine that you are explaining the algebraic operations, the addition and subtraction and multiplication. You just explain them, but it's not enough. You need to give examples and you need to show to people how they work, how to add, how to actually add two numbers, how to actually divide two numbers, and so forth. Right? We are just exploring the different types of operators on logical statements. How do these operators actually work? We're going to see this in the next lecture. Okay, the last one, if and only if statements, sometimes known by the biconditional. So the if statement is called the conditional. If and only if is known by the biconditional, and this is the symbol. We're going to use it whenever we have this biconditional operator. You see, if you are sick of saying if and only if, you just put or write it if and only if, you just write IFF. Of course, when you have IFF, you don't read it IFF, you read if and only if. So it is a widely known, I would say, abbreviation in mathematics. Whenever you see IFF, you read it as if and only if. And this is the symbolic representation of that. And how are you going to read it? It says P if and only if Q, or Q if and only if P. Because this operator is a commutative operator, means that it doesn't matter which one you put first, but the conditional matters. And the one we just finished, it does matter. Here, the order in which you put P and Q, it does not matter. We'll see that later also. Okay, well, here's an example. Alex plays goalie on the lacrosse team. Right, that's a statement. Yeah, that's his true or false. We don't know about Alex, maybe but it is a statement. It's a logical statement, and we are going to denote that by P. And what's Q? The Huskies win the championship cup. Okay, so now it says write the statement in symbolic form. Well, what statement? Oh, well. Okay, well, here it says write the statement in symbolic form, means translate this, right? Into write it down. You should write the English of this thing here. What does it mean? P plays well, you can say Alex plays goalie in the lacrosse team if and only if the Huskies win the championship cup. Well, just like I said, Alex plays goalie on the lacrosse team if and only if. So this one here would be translated to if and only if the Huskies win the Champions Cup. How about this one here? What is Q? Q is, again, the Huskies win the Championships Cup. So here the Huskies win if and only if Alex is not, or he does not play the goalie for the lacrosse team. Here it is. So Huskies win the Champions Cup if and only if Alex does not play goalie on the lacrosse team. So when you have this, you just translate this into not, the negation. Well, how are we going to translate this? Remember, when you have this outside, you can translate this. You're saying that it is false that. So we're going to translate this. It is false that, and then you keep working on the translation here. So what is P? P, Alex plays goalie if and only if the negation of Q. What was Q? The Huskies won the cup. So I'm going to say it is not, it is false. Or you can say it is not true that Alex plays goalie if and only if the Huskies won't or does not or don't win the cup. So it is false that, like I said, Alex plays goalie if and only if the Huskies don't win the cup or the Champions Cup. Okay, well, here is a table that sums it all, really. So I know this section is confusing, and please, I don't want you to be anxious about it too much, because what we just did in this lecture is just to introduce this brand new operators, because we are so used to adding numbers and dividing numbers and so forth. We're not using to work on logical statements. So this lecture is just to tell you, well, yes, we don't just we just don't have just numbers. We have statements and we have sets, and for each mathematical object we have some operations and operators that work with them. So for logical statements, we have these 5 operators: the negation, the conjunction, the disjunction, the conditional, and the biconditional. And this is how you read it. If you have something like this, this is the not operator. This is the or, I'm sorry, this is the and, the or, if, then, and if, and only if. And this is how you symbolize it. Well, I hope that you get a small idea about these things. When you see them, you don't freak out. You don't say, what's going on? At least you can translate them into words. In the next lectures, we are going to actually dig in and explain every single one of those 5 operators more in detail. And hopefully by the end of this module, you will understand how to work with logical statements. Well, until then, please try your homework and then to the next lecture. Talk to you later.